This video is going to focus on operations with functions, and by operations I mean adding, subtracting, multiplying, and dividing, as well as we have some new operations that we're going to learn. These operations, adding, subtracting, multiplying, and dividing, are ones that we've been working with all year long, so it's not really anything new, so that part should go quickly. Basically though, when we're talking about operations with functions, we're essentially adding two functions together. And the way you do that is just like you would add two polynomials together. And so if I look at what I have f plus g of x. Now one thing to notice is how it's written, like the notation of it, to see what's going on. This does not mean f plus g times x. It's just a shorthand way. It's just another way of saying f of x plus g of x. And it's just a different way of writing that. But they mean the same thing. And so what I do is I just take f of x and I add it to g of x. So here's f of x, here's g of x. I add them together, and we know that we just add like terms. As it turns out, with what I have a positive 5x and negative 5x. I'm just adding like terms. That adds up to 0x. Negative 6 plus 6 adds up to 0. So this is a strange one. It just comes out to be x squared. It doesn't always happen that oddly that things drop out. All right, well, if it's f minus g of x, once again, that means f of x minus g of x. And so I'm going to take my f of x, which is 5x minus 6, and I'm going to subtract my g of x, which is x squared minus 5x plus 6. We know that addition is commutative. You can move things around, but with subtraction, it's not. We have to put it in the correct order. Another thing to notice with this is there is a minus and then there's a parentheses. And so we have to make sure that we are essentially distributing that minus sign. And so this is going to come out to be a negative x squared. And then my x's, I have 5x minus negative 5x. That's 10x. And then I have negative 6 minus 6. That's minus 12. And so once again, adding and subtracting is just basic, straightforward. We've done that before. Maybe the only new part is just understanding what this notation means. And that's what it means, f of x minus g of x. Does not mean times. Okay, then I mentioned in the beginning that we have a new operation. So adding, subtracting, multiplying, and dividing, but here we have something called a composition of functions. And so we have f of g of 3. Well, how do we work out f of g of 3? Well, one thing is you start on the inside and you work your way out. So in other words, we're going to start here with g of 3. We're going to work that out. And then once we get that answer, then we'll go to f of whatever. But we're going to start with g of 3. And similar to what I was talking about with subtraction a second ago, these are not commutative. In other words, order does matter. Okay, so we're going to start on the inside with g of 3. Well, here's my g function. G of 3 just means I plug in a 3. So that's 3 squared, that's 9. Then, now that I've gotten my g of 3, now I want to plug that in and do f of 9 in this case. So f of 9, I'm going to take that 9 and I'm going to plug it in for my x, and I get 2 times 9 minus 3. And so what I've done is, first of all, I figured out that g of 3 was 9. Now I'm taking that 9 and I'm plugging it into my f function, and I'm going to work it out. So this is going to be 18 minus 3, or in other words, 15. So that's how you do composition of functions. You start on the inside, you work your way out. Well, like I said a minute ago, they are not commutative. In other words, order does matter. So f of g of 3, we had to do g of 3, work it out, and then plug in for f of x. Well, on this next example, it kind of looks the same, but this time we have to do f of 3 first, and then take that and plug it in into the g of x to see what it's going to work out to be. And so f of 3, here's my f function. I'm going to plug in a 3 there for x. That's 2 times 3 minus 3. That's 6 minus 3, and that's 3. So f of 3 is 3. I'm going to take that 3, and I'm going to plug it in now to the g of x function. So I'm going to come up here, and I'm going to put it into that spot there. And so I take the 3, g of 3 is 3 squared, which is 9, and so my final answer is just going to be that g of f of 3 is equal to 9. So that's how we do composition of functions. Again, the main key is start on the inside and work your way out because these are not commutative. You have to go in a specific order. Okay, let's turn the page. Okay, on the previous page, let me go back to the previous page for a second. On the previous page, we were looking at f of g of 3, or g of f of 3. There was a number involved. On the next page, instead of having a number, we're going to look at something like g of f of x, where we don't have a number involved. So we're not plugging numbers in. We just have variables. So that's what's going to be on the next page. So first of all, we've got some information here. What is the composition of functions and what is its notation? Kind of like what I was talking about a minute ago. You probably have never seen this notation before. This notation, this little dot, and people say dot, f dot g of x. That's what we say, f dot g of x. Or you could say that f of g of x. And so we talked a minute ago about how we do the inside part and work our way out. Same thing if it's in this notation. These two are just two different ways of saying the exact same thing. They also have a note here about the domain. We're not going to worry about that too much, but I do want you to notice the notation. That's what I want to point out here. So here we have two different functions, f of x and g of x. It says if f of x and g of x are these, find the following composite functions and state the domain of each. So in the previous one, we took an x and we plugged it in, and it was a number. In this case, we don't have a number. We're just going to plug in an x. Well, x is already plugged in, so that's done. So now what we have to do is we have to take that function and plug in the whole function because it's simplified as much as it's going to be simplified, and plug it in to the x value in the other function. So here's what we're going to do. We're going to say f of g of x, that's just what we have written down here, is equal to, now I'm going to plug in my inside function, that's g of x. I'm going to plug that into the outside function, that's f of x. So I'm going to take radical x plus 2, and I'm going to plug it into the f of x function. So just make sure you see what I've done. I just took that whole function and I plugged it into that x. All right, now that I've done that, I just need to multiply it out, simplify it, whatever needs to be done. So I'm going to go ahead and multiply this out. I get 3 radical x plus 6, and I still have my minus 4. And that 2 is not under the square root sign, it's all by itself, and so that 6 is also all by itself. And so this is 3 square root x, and then we have 6 minus 4, well that's 2. And so f of g of x is 3 square root x plus 2. Sometimes I like to put a little end cap on that to make sure we understand that's where it ends. Okay, so that's all you do. You just take one function and you plug it into the other function and then work your way out. In other words, start on the inside, work on the outside. Again, two things here. It is not commutative, order does matter, and this notation, g dot f of x, just means the exact same thing as g of f of x. Does not matter which way you write it. Well, same thing here. This means f of g of x. And you can write it either way. So that little dot means composition. It does not mean multiplication. All right, so on this example, I have f of x is on the inside. The innermost part is f of x. So I'm going to take whatever that is and plug it into g of x. So here's my g of x function. I need to plug in this f of x, this 3x minus 4, into that function. And this square root sign should go over that whole thing up to 3x minus 4. All right, so now we need to simplify, if we can. Well, in this case, there's not really a simplifying to do. That's not going to simplify any further. So we are done. We're just going to say g of f of x is equal to the square root of 3x minus 4 and then plus 2. So that's going to be our final answer. If we think about that concept of the domain for just a minute, what are the domain of these two functions? Well, f of x, what I'm asking is when I say what is the domain, what numbers could be plugged in for x? Well, in f of x, all real numbers, there's not really any restrictions. You could plug in a negative, you could plug in a fraction, you could plug in anything into that x, and it would still give you an answer. But on g of x, there is a restriction. Let me first of all say this is the domain. So the domain is all real numbers. So the domain of f of x is all real numbers. The domain of g of x is what? Well, can we plug negatives in there? Not really. So the domain on this one is x is greater than or equal to 0. Because if x is less than 0, we'd have a negative number that wouldn't work. So our domain is going to be x is greater than or equal to 0. Now when we plug it in, there might be more restrictions as well. So this one is still remaining as the domain is x is greater than or equal to 0. But this one is not greater than or equal to 0. It actually has to be 3x minus 4 has to be greater than or equal to 0. So in other words, 3x has to be greater than or equal to 4, so x has to be greater than or equal to 4/3. Again, I'm not too concerned about the domain, but that is what they're talking about when they ask about domain. Two last problems, they are really just more review problems. So we can just work through these probably pretty quickly. F of g of x, in fact, you might want to pause it and see if you can do these on your own. So pause it and see what you can do with this. Okay, so let's look what you came up with for these last two examples. For 4a, you should have gotten 5x squared minus 7 because you plug in the x squared minus 1 into the x position here, and you distribute that. That's 5x minus 5. You still have a minus 2, so that's 5x squared minus 5 minus 2. That's minus 7. On the next example, your final answer should be 25x squared minus 20x plus 3. Because you're plugging in 5x minus 2 into the x, you have to square it. And if you're not sure where I'm talking about, right here in blue, I'm squaring it. So I square it, and I get 25x squared minus 20x plus 4, but I still have the minus 1. And so when I simplify that, I get 25x squared minus 20x plus 3. Okay, take a few minutes to write something down in the summary. What are some things you need to remember about this? How do you do composition of functions? How do you do addition and subtraction of functions? What is the notation? Things like that. And we will work on this in class tomorrow.